particular restaurant, each slider has 225 calories. Each chicken wing has 70 calories. A combination meal with sliders and chicken wings has a total of 7 sliders and wings altogether, which contains 1,110 calories. Which now our first step was we needed to make 2 equations, and the first thing was we needed to define our variables. And the way I like to define my variables is I look at what the question is asking for. Determine the number of sliders and number of chicken wings in the combination meal. So that's usually what I like to make my variables, is what I want to find, which is number of sliders and number of wings. And then we use this extra information that we have to make 2 equations with 2 variables. So I have a total of 1,110 calories, and the combination of that is going to be 225 times the number of sliders, right? If there's 225 calories per slider, then I would simply times 225 by however many sliders I have to figure out how many calories I ate, right? And same thing with the wings. If wings are 70 calories a piece, I would simply times 70 by how many wings I had to figure out how many calories I ate in wings. And when I put all of that together, I should get the total 1,110 calories. And then here it says the combination meal had a total of 7 sliders and wings altogether. So if I put the number of sliders I have with the number of wings I have, I should get a total of 7 items, whether it's sliders or wings. And so after we have found that, now we have 2 equations, 2 variables we can solve, right? Except now, you know, these might not turn out like these are some big numbers, right? And they're not necessarily super low and nice like Delta math numbers are, but the things are all the same, and we can solve this however we would like to solve this. Personally, with something like this, I'm a fan of substitution. I don't really mind which one we do, but I'm going to take this bottom equation, this s plus w equals 7, and I'm just going to subtract w. So if I take s plus w equals 7, I'm just subtracting w on the other side, so I get s equals 7 minus w. After I do that, now I'm going to do the substitution game. So I'm going to substitute this back into this top equation for s. So I see 225 times s, which we just said is the same thing as 7 minus w, plus 70 w equals 110, right? And now we just distribute that 225. 225 times 7 is 1,575 minus 225 w plus 70w equals 1,110. Oops. All right, so minus 225w plus 70w simplifies to negative 155w. Then we solve that 1575 minus that. And then subtract the 1575. So 1,110 minus 1575. Then divide by negative 155. And we get that the wings W equals 3. And so after we just do all that math, that's just substitution, we get that we have 3 wings. And you remember we have to plug it back in to find the other one. So I think that bottom one is definitely easier, right? S plus W equals 7, or S plus 3 equals 7, subtract 3, we get S equals 4. And so we don't really have an ordered pair this time, but what we're saying is that the number of sliders we had in this combination was 4, and the number of wings we had in this combination was 3. And you really don't even have to plug it back in if you understand the question, right? If there were 7 sliders and wings altogether and we had 3 wings, kind of just makes sense that we'd have 4 sliders left, which is what this equation is giving us over here. So the answer is 3 wings and 4 sliders, right? So it's solving, which we've done plenty of, but now, just make sense of it, which is why I think labeling it W and S for wings and sliders is better than like X and Y, because at the end you can say, okay, the number of wings we have is 3, and the number of sliders we have is 4. And you should look back to your original, what you set S and W equal to figure out what they are. Any questions on this one? Okay. So Sydney is going to a carnival game that has games and rides. Each game costs $125 and each ride costs $225. Sydney spent $24.25 altogether at the carnival, and the number of rides she went on is 3 more than the number of games she played. So thinking of 2 equations to make, right? If she spent a total of $24.25 and each ride was $225, or $2.25, and each game cost $1.25, then, well, first I made my variables right, number of games, R is number of rides, and again, determine the number of games and the number of rides. So that's why I like to make my variables what I'm looking for, right? So number of games, number of rides. If it costs 125 per game, then 125 times the amount of games would give me how much I spent on games. And if it was $2.25 per ride, 200 or $2.25 times the amount of rides I did would give me how much money I spent on rides. And you add them together to get the total amount of money I spent, which is, or Sydney spent, which is $24.25. So that's how we get this equation. And then this one tends to mess with people. So she went on, the number of rides she went on is 3 more than the number of games. And it's a little weird to put the +3 on the games, but when you can think about it is the amount of rides is going to equal the amount of games plus 3, right? Is going to have 3 more games, right? The rides is going to equal the amount of games plus 3 because it has the rides are 3 more than the games. So that's how I like to think about that one. And again, with these ones, these tend to trip people up, this wording here. But plugs, make it make sense, right? If if it says she went on 3 more rides than she did games, and I say, okay, well, if I went on 4 rides, then I should only go on 1, or I should have only played 1 game, right? 1 plus 3 is 4, so that makes sense. And now, once you would have this, we would just solve it. And again, R is already solved for in this equation, so I am going to do substitution. I have 1.25 times the amount of games I've played plus 2.25 times R, which down here we said R is G plus 3 equals 24.25. So we have 1.25 times G plus distribute the 2.25 times G, and then 2.25 times 3, 6.75 equals 24.25. $125 and $225 is going to make 3.5 G. Subtract this 6.75. So those cancel. 25 minus 75 is going to leave us with 2350. Minus 6 is going to be 1750 divided by 3.5. And the amount of games we get is 5. Okay, now I want to know the number of rides she went on. So I'm going to take the amount of games she played, which is 5, and I'm going to throw it back up here. This equation where R equals G, which we just said is 5 plus 3. So the number of rides she went on was 8. And that makes sense because up here we said the number of rides she went on is 3 more than the number of games. 8 is 3 more than 5, so she played 5 games and went on 8 rides, is what it would be in the context of this problem. I'll leave this up a little bit in case anyone is still writing. Any questions on this one? And if you plug 5 and 8 back in, it should make sense in both equations, right? So if I plug 5 in for G and 8 in for R, I should end up getting 24.25 on this side. And maybe I'll do it on the calculator just to be sure. 1.25 times 5 plus 2.25 times 8 does indeed equal, let me see if you can see me, 24.25. So it's good. Quick way to check. Okay. Probably only have time for one more. So Lincoln has set up a lemonade stand outside his house and sells small cups and large cups of lemonade. Each small cup holds 6 ounces of lemonade, and each large cup holds 18 ounces of lemonade. Lincoln used 780 ounces of lemonade and sold 4 times as many large cups as small cups. Write a system of equations that could be used to determine the number of small cups and the number of large cups sold. So number of small cups, number of large cups, that's what I'm making my variables, S and L. And now we're going to solve this. And the equation makes sense, right? Because the total amount of ounces we had of lemonade was 780. And I could figure out how many ounces of that came from small cups. If small cups are 6 ounces, 6 times the amount of small cups is going to give me how many ounces came from small cups. And if the large cups were 18 ounces, 18 times the amount of large cups is going to give me how many ounces came from large cups. Put them together, and you should get the total amount of ounces. Now this other one sold 4 times as many large cups as small cups. So again, this is the one that feels a little backwards because we do the 4 times the S, right? But if you read it out loud, it kind of makes sense. The large cups, you sold as many or equals 4 times the amount of small cups, right? So, for example, if you sold 2 small cups, you would expect to have sold 4 times as many large cups, or 8. And if we plug that into this equation, it makes sense, right? 4 times, if we said we sold 2 small cups, do we get 8 out? Yes, we do. 4 times 2 is 8 large cups. So that's how I think about those. And now, again, substitution is a great one here because we have L equals 4S. So I'm going to rewrite this top equation, 6S plus 18L, but L we just said is 4S equals 780. So 6S plus 4 times 18. I could definitely do that on my end, but 72. 72S equals 780. And this one's kind of nice. 6 plus 72 is 78S. Right, divide by 78. And we should get that S equals 10. Okay, so we have S equals 10. We're going to plug that back into our equation up here. L equals 4 times S, which we just said was 10. So I found out that I've made 40 large cups and 10 small